So let's see how this goes. This midterm exam review, 41 questions. I'm going to do my best to get through all of these. I thought I'd better start a little early and get a few posted to you. So I think tonight, if I can make it through about 20, I'll be doing good. Let's see how we do. So we've got this first question on limits. The limit of the function as x goes to 5. So let's get it nice and big. So this is saying as x goes to 5 from both directions, what's happening to the y? We come up here, actually there is a value, a point there, so the function here is increasing. Function here is so coming from the left and coming from the right, they're really going to the same point. The point they're going towards is y equals 7. Okay, and this point is actually exists. So 5, 7. But the limit, we'll say, is 7. And by the way, you can you can go through this faster if you need to. You can also go you can speed it up, you can move it forward. So anything that you understand, just go ahead and do. Move forward, and I'll try to pay attention and make sure I'm getting the right answers. That's what I like about this. It'll check us each time. Okay, that one's not too bad. Let's go to question number 2. Now this one, it wants us to check the limit, but it wants us only from the right hand side. So as x is going to -2 on the right hand side, so let's just make it larger. It's always easier, at least for me. So we're going towards -2 this time, which is here is the -2. So, and we're only interested in coming from the right. You notice there's a disconnect. There wouldn't be a overall limit, but coming from the right, there actually is a limit. Now there's no function value there, but this, as we go along this road from the right, we are heading to the destination of y equals 4. Y equals 4 right here. Okay, so that is our limit. Y equals 4. Well, 4 from the right hand side. Get out of there. Let's clear out the screen. Get that mess out of there. So we will say that there is a limit from the right, and it's equal to 4. Now, no, there is not because the left-hand limit is different, but for this one, we're good. Okay, so right-hand limit does exist. Let's go to the next 3. So now we want to graph a function, then find its specified limits if necessary. So, or if it doesn't exist. So f of x equals absolute value of x. Find the limit as x goes to 0, and find the limit as x goes to -6. So first, we got to graph it. Absolute value is the v-shaped function, so we go there, and it's just simply absolute value of x is going to have, 2, 2, 3, 3, all those. So this is going to be our graph of the absolute value of x. Now as we go towards 0, let's go ahead and bring that back up. The limit, again, oops, I don't want to do that. I want to do this. So the limit from the left and the limit from the right, they're both going towards the value of 0, the y value of 0 when x is 0. As x goes to -6, we see the same thing. I'm just going to do them both at the same time. So as I come from the left, I'm going towards +6, and as I come from the right, I'm also getting close to +6, a y value of +6. Okay, so those are going to be our limits. I think I have to save this again, or maybe I can cancel it because I've already got it there. Let's clear those things out. And So we can say, remember, the limit as x goes to 0, the limit is also 0. 0. And then as x goes to negative 6, the limit is positive 6. It's the y value that we're interested in. So at negative 6, we go to 6. So those are our limit questions. Good job. Compliment myself, right? You gotta compliment yourself, right? So determine the value of c so that the limit of 2 does actually exist. So notice 2 is actually not even in this domain. We've got something if x is less than 2 and something if x is greater than 2, but we don't have any value for what happens when x equals 2. But if we're going to have something so that the limit were to exist, we would need it the top function is less than 2, so this is coming from the left. This one's coming from the left, and this one is from greater than 2. We'd be going this way. So what do we need c to be? Well, we need x squared minus 7 when x is equal to 2. We need that to be equal to negative x squared plus c. Now, we don't need it everywhere to be equal. I don't think we could get it equal, but when x is 2, we do need them equal. So what we're going to do is we're going to plug in 2 for x. So we get 2 squared minus 7 needs to be equal to minus. Now this is where it gets a little tricky. That minus is on the outside. Whenever we plug in for x, we plug in nice and tight. So there's a 2. So we're going to square it first and then put that negative on it. So we get 2 squared is 4 minus 7. That needs to be equal to 2 squared is 4. So we get a negative 4 plus c. 4 minus 7 is going to give us negative 3 equals negative 4. Add 4 to both sides. And we get that c is equal to positive 1. That is what's going to make it work. Okay, add x equals 2. That's what we need to have happen. And you can kind of check it, I guess, is x squared minus 7. As we get close to 2, is that going to be the same thing as this? It's got to be now, right? Minus x squared plus 1. It's got to be the same as this when we're getting to 2. And the way we've done this, if we put a 1 here, we'll see we get negative 3 negative equals negative 3. Okay. Try it out. But what we need is we need c equals 1. 100%. Get rid of all the writing. There we go. Let's see, again, my goal, get through at least 20 tonight. Let's see. So now find this given limit as x goes to 7. You know, we could look to the left, look to the right. We could use the graphing calculator. I'm going to use the graphing calculator anyway. There's also something we would have learned that polynomials, this is continuous, so the limit as x goes to 7 is going to be the function value as well. But we'll go ahead and plug this in. So I'm going to graph this minus x squared plus 3x minus 7, and so make sure I got it in there right. I'm going to go to the table, second table, and let's see what's happening as x goes to 7. As x goes to 7, there's a function value of negative 35. We can feel pretty doggone confident that that's what that's going to be. If, you know, just to emphasize, what we can also do is we can go second table set. We can change it to ask. And watch, I'm just going to see if that's really what's happening as I get close. Again, we could look at the graph, but as I get close to 7, so if I'm at 6.9. Notice I'm pretty close to negative 35, and again, you could just kind of start sneaking up on it, get it a little bit closer. That's getting pretty close. If I put 7, I'm going to be exactly at 35, and on the other side, 7 point, kind of close from the right. We're as close as we want to be. Maybe not quite that close, huh? So we get close to 30. Anyway, that's our answer. We're going to stick with it. Again, for the test, you can pretty much, if we've got a polynomial in here, the limit is going to be the function value. Okay, this question, use a theorem on limits of rational functions to find the limit. If necessary, state the limit that doesn't exist. So again, on this one, we what we can look at is the limits of rational functions. So limits of rational functions basically says something like if well certainly we plug in 10, we get division by 0, it doesn't exist. But what the limit of rational functions states that if we could reduce this, then the limit will exist. Now you could just graph it if you want, but x squared minus 100, that is x minus 10 times x plus 10. That's how it factors. It's a difference of squares, right? So then we've got x minus 10. This is going to cancel out. That's 1. So this is going to behave the same as just x plus 10. And if we put in 10 here, 10 plus 10, we're going to get 20. Okay, we can say the limit does exist. It's at 20. Now, again, we could come here just to verify, show you some techniques that you can use. I want you to be able to understand and know, well, what if I get something different? So I'm going to go parentheses. What if I don't know how to factor it? I didn't see that that was a difference of squares. I'll just graph it, x squared minus 100. And again, please do feel free to fast forward if you've looked at this and already understand it. I try to take time and show a couple different ways just so that I make sure that it's all making sense. Now, what we're going to do is we're going to go to our table, and remember I've got it set up on X. Let's plug in 10. We should get an error, right? We do, because it's a division by 0. But if we go to the graph, or like we're here, we could plug in something close. So let's go 10.01, close to 10 from that side. That's about 20, a little bit bigger than 20. If I went to 9.9999, put that in, and I'm at 20, so that's good. And then if we graph it, look at the graph. Again, I want to be able to go up to 20, 10, and 20. So I've got to set my window, and let's make our Y max. Let's go to 25, because again, I'm saying they're going to go to 20. So we see this coming through. Now, there's actually a hole there. We wouldn't see it. I guess I better go out a little bit more. I want to go bigger than 10. Let's go to 15. And you'll see, from what we see, it looks like it's continuous. It looks like just a straight line. But there's actually a hole there if we were to try to trace, right? If we go to value, and then we plug in 10, it goes there and says, whoop, there's no Y value. So anyway, that's what we do. Okay. Let's see, what's our answer? 20. The limit was 20. Okay. That's good. Okay, let's go to 7. Whoa. Initial substitution of x yields a 0 over 0 form. So then simplify algebraically, so forth and so on. Okay, so again, you can't quite get away from plug in 11, the difference of squares, a factoring. However, again, you could look at this graphically. Just graph it. You'll be able to find that limit. just like we did the last one. But what we're going to do is it's a similar type deal. This is a difference of squares, so this is 121 is 11 squares, so that's x minus 11, x plus 11. Now, if this is going to work, we need an x minus 11 in the top. I just, by teaching so many years, you kind of figure these things out. This has got to factor into an x minus 11. So if it's an x minus 11, what is the next one? Well, what's 154 divided by 11? I don't know. Let's use a calculator. I probably should know. I mean, but it's beyond my immediate reach to know those kind of the powers of 11. I'm gonna guess what is 13 or 14. 14. I was in the ballpark. 14. So this must be here x plus 14. And again, I was going to, what I could have done is I know that I end up with a plus 3, so it has to be 3 bigger than 11, and it'd have to be positive. So this works. You get your negative 154, you get a plus 3x in the middle. The main thing is, though, we can cancel this out, and now this is what, this is going to exist. We can plug in 11 here and find out what the value is. So we get 11 plus 14 in the numerator, and we get 11 plus 11 in the denominator. That's going to give us 25 in the numerator and 22 in the denominator. Integer or simplified fraction. I think that's all we can simplify. Looks good to me. 25 over 22. So we'll bring up the function tool. 25 over 22. Now again, you could do that with, let's go down. You could do it with the graph, but then finding, anyway, this is a better way to do it. Get it. Would have found a decimal probably, right? So they give us these kind of answers. Let's go with that. Okay, question 8. Determine the following. Okay, now we're going out to infinity. Now remember, when we go out to infinity, this is, you can kind of just apply the algebra rules here, just something you should have had in college algebra. And whenever we're looking basically for the horizontal asymptote. What line is it going to? So we see that the largest degree in both the top and the denominator is the same. So this, we could basically say this stuff is just small potatoes once we get really big. When x gets so huge, this part is going to be so big, the other stuff doesn't matter. So it's going to behave like 24 x to the third over 56 x to the third. Now x to the third cancels, that's going to give us a factor 1, so it's going to behave like 24 over 56. They want it simplified. Oh, there's a box there. I forgot. 2 goes into both of these. 2 goes into 24 12 times. 2 goes into 56 25 plus 3 is 28. And we just keep going. 2 goes into both of these, so 2 goes into that. So I get 6. 2 goes into 28. That's 10, 14. We keep playing the game. We could have gotten the largest, but we just keep going. 2 goes into 6 3 times. 2 goes into 14 7 times. So 3 sevenths. 3 sevenths. Very good. Looks like Little Crow might actually know what he's doing. Some days I do, some days I don't. Okay, we've got question number 9. We're still with limits. I've actually not looked at the I'm assuming the test is probably about 20 questions, 19 or 20 questions. I'll take a quick look before I finish all of this, and I'll verify that, but And I'll put in an announcement as well. But right now, we're busy, right? We're making progress. So use the graph to answer these questions. So find the limit of as x goes to 4 from the right and from the left. So let's make this large. It's easier to talk about. It's easier to see what we're doing, or at least it's supposed to be. Oops. Yeah. So I guess these are ones. So 1, 2, 3, 4. That makes sense. Okay. So coming from the negative side, from the left side, we're getting close to 4 here. The y value, though, is getting close to 2. Coming from the right-hand side, as we get close to 4, right? There's the left, there's the right. The y value is getting close to this value here, and that's 2, 3, 4, 5, 6. Okay. And then they're going to ask about find the function value at 4. So if we plug in 4, what do we get? Well, it's telling us it's right here. It's actually 6. So f of 4 is equal to 6. Now again, the limit itself, the overall limit doesn't exist. I don't know if it's going to ask that or not, but the left and right, they exist, but they're different. Okay. So we can say the limit as we come from the right, remember that's going here, that's going to be 6. The limit coming from the left, that is the lower one, and that we figured out was 2. Now it doesn't exactly, the point doesn't exist there, but it's going towards 2. And then finally, the limit itself, notice this is not left or right, both sides are not the same, so we say the limit does not exist. But the function value itself does exist. When I plug in 4, as we see, we get this solid dot here, we do get 6. So is it continuous? Well, that doesn't look continuous to me. That's a jump to go from there to there. Continuous means you could draw this graph without lifting up your pencil or pen or mouse, I guess. So no, it's not continuous. But now what's the reason? F of x is not continuous at x because f of 4 is undefined. Well, no, f of 4 is defined, but it's not continuous because the limit does not exist. That's the reason. And let's see, there's a couple others. Nope, it's not. This is a yes and a yes. So it has to be B. We're doing pretty good. Okay, got to 10. Halfway there. So we've got a piecewise function here. I like to look at numbers first and see the patterns. We've got 35 is going to be the handoff. And most of these questions are about, what happens here. So let's see. Candy factory sells candy, charging $1.75 per pound for quantities up to and including 35 pounds. So up to 35 pounds, we're going to have $1.75. But then you get a volume discount as soon as you buy above 35 pounds of candy, and they change the price to $1.30 times the pounds plus some sort of constant. And now the goal is that we want these to be equal. So like we did the other one, what has to happen? Well, when x is equal to 35, for this to be continuous, then these two have to be equal, because that's, they're both continuous everywhere else, and if they're equal at 35, then it's like handing off the baton. They can do it. So when x is 35, we have to have 1.75x equal to 1.30x plus k. And again, it doesn't have to happen everywhere, but it does have to happen when x is 35. So 1.75 times 35. I think, let's see, make this a little bit thicker. I think it works better. There we go. That's 130 times 35 we'll figure out our constant. So again, on tests, bust out the calculator. It's a good way to make sure you're doing everything, and it's a little bit faster. 1.75 times 35. It gets us let's just put down here 61.25, and then 130, 1.3 times 35. Oops. My biggest problem is I get in the hurry and I don't always check what I'm writing down. 45.5. Plus some constant k. So I subtract the 45 from the 61.25, and I don't have to show all my work. I can just do my work. So at 61.25 minus 45, oops, 0.5. See, some I tell you, I should. That's why, you know, when you use the calculator, it helps you see exactly what you're doing. Sometimes, if you pay attention. There we go, 1575. Now, yeah, that's what it is, 1575. So we got to make k 1575. Put that down. And so k needs to be 15.75. And just so you know, with these limit things, we just, it has to be at that place where they're equal. Okay, 1/4 of the way there. Here we go, we've got a graph. It's showing trips taken annually. We've got some open circles here. The average rate of change from 92 to 95. Okay, here we go. Round to 3 decimal places is needed. So this is getting us our average. This is really just slope, right? 92 to 95, we come here. So we've got you could, well, let's just, it's going to be, remember, y over x. So we've got 2 points, so this point is 1992, 8.5 is our million, and then 1995 is right here, and this is our y value. So y2 minus y1, so we get 1992, we had 8.5, and we can see it's a decrease, so hopefully we end up with a negative answer. And we get 1995, 7.6. You might see this in some of the videos I did if you watched any of them. I use this technique from ancient India. If you just line up the points and then you subtract, so 1992 minus 1995, well, that's 3. It's going to be negative because 1995 is larger. Then we do 8.5 minus 7.6. Well, that is borrow 1, 15, 6 from 15 is not as 0.9, right? And then we take the x and tuck it underneath the y. So 0.9 over negative 3. So good, we got a negative slope. 0.9 divided by 3 should be 0.3. Or is it 0.03? It's 0.3, isn't it? I think it's 0.3. And again, always good to just check it out. Yeah, 0.3, that's what I was thinking, but you know, with decimals and division, sometimes it just doesn't seem real. So there we go with that. Round to 3 decimal places. Well, yeah. Okay, there's 3 decimal places. The average rate of change from 95 to 2000. So now we come back here. I'm going to clear off all this stuff because we're looking at some new points. Okay, so 95 to 2000. So again, here's our 95. Here's our 2000. This is our y value, right? And at 2000, that's one of those things. I guess I could make the graph bigger, but it's going to be 9.5. Okay. Hard to see everything at the same time. So, okay, so we'll do the same thing. 1995, comma 7.6. That's 1 point. And then 2000. And what was that? That was, sorry, I forget. 9.5. And that should be a positive slope as we see it going up. So when we subtract now, we get a negative number. We get -5, right? 1995 to 2000. But we're also going to get a negative here. 9.5 subtract 7.6. That should be 1.9. And then again, we take the 5, tuck it underneath here, so that's -5. So negative is going to make a positive. When I pull up my calculator, I'm going to check all my calculations because I tend to, when I put the big one on top, but I'm doing it all visually or mentally visually, and I just sometimes do it, you know, make a calculate. Okay, that's good. And then we can divide that by -5. And we get positive 0.38. 0.38. And we'll put a 0 on there, 3 decimal places. Okay. And we're going to clear this out. And then finally from 92 to 98. Okay, so that's why they give us this number here. And again, we just do the same thing. So you get it down, get your system down of how you want to do things. So we'll go with 1992. It doesn't really matter which one you put first. And then 1998, 8.7. And notice it's going to go up a little bit, so it's a positive slope. 92 minus 98, that's going to be a -6. And then 8.5 minus 8.7 is going to be a -0.2. And then again, we take the x, tuck it underneath the y. So -0.2 divided by -6 is going to be a positive point something. I know you could reduce it, but 0.1/3, 1/30th, just a little bit. So we could just put in here 0.2 because we've already taken care of the negatives, divided by 6. This time we do need our 3 decimal places, 0.0333. Yeah, I know it was something like that. 3 decimal places. Let's clear that off. Check our answers, and we're doing good. Okay. So again, it's build your confidence, practice, practice, practice. Just get these down one way or the other. And let's see, the end of day values of a stock market index for the week. This is our graph to the right, where X is the day of the week or the day of the month. On what day did the index show the greatest rate of increase? Greatest rate of increase. So it has to be going up. Hey, there's really only, I mean, I don't see all the details, but it is going down, 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 down. It's right here when it went up. Okay, so we'll make it nice and big from 12 to 13. That's, so December, let's see, what's the question? It's going down, down, down. These are, let me read again. The end of day values. So at the end of the day, on the 12th, it was down here. It's at the end. On what day did the index show the greatest rate of increase? So when it opened on the 13th, it was down here. So this all happened during the day of the 13th. Okay, does that make sense? Had to have happened on the 13th. Not only the greatest increase, is the only day of increase. It's like the, oh, we're not done. The rate was, oh, no, that. I thought that would be too easy, right? They want us to, what was the greatest rate of increase? The rate was blank points per day. So, but it's not too bad. We can just 15, 7, 85, 15. Oh, see, my dyslexia, I was thinking those numbers were exactly the same. But it's just a 1 day increase here, so we just need to subtract those two numbers. Not too bad. And they are different. So we go 15,875 minus 15,785. 15,785. I was seeing this. This is wait, 90. So when it went up 90 points in 1 day. So what else? On what day did the index show the greatest rate of decrease? Well, you can kind of see it, you know, which one is the longest. It's this section here. It was actually on the 11th. Again, remember, it's the ending values that we've got here, and you could do the calculation, but it's this is the steepest down visually, and if you were to subtract these two, you're going to get that. So I would say, let's show it again. It's the 11th, right? Because here it goes down. I don't know, you could do the subtraction here. I can just see visually it's going to be more here. So I'm just going to go with the visual. They probably want us to calculate it anyway, but I'll go ahead and do that. So it's December 11th was the day, the greatest decrease. And what was it? Yeah, you knew it. They were going to ask us. So we take the ending value from day 10 and subtract the ending value on day 11. And again, you do have to be careful. They don't always show. Sometimes they're not to scale, they'll say, but this one, they've got the numbers here. We were at 15,967, and we subtracted at the end of the day 11, we only had 15,867. 100 points, that was a 100-point loss. I can see this is not a 100-point loss, right? 867 to 785, didn't get all the, okay, so this was 100 points per day. Simplify your answer. I guess that's about as simple as it gets. Let's check it. Oops, I messed up somewhere. What did I do? On what day did the index show the greatest rate of increase? On what day did it show the greatest rate of decrease? Give the rates. I may have 967. That's definitely 100. Maybe I messed up here. Is that 90? That looks like 90. day 11. So on day 11, it started up here and it lost down to there. Day 13, we got the greatest increase. One of these is wrong, and I'm not sure which. Oh, I'll bet you it's one of the days, but 13 is right. The 11th is right. Because it's how much it changed from the day before. So the end of the day 10, and then it marks, and then the end of the day 11, that's 100. Now the increase has to be right. 13th. What did I do? 190. That is 100. That's 90. Well, I'm just gonna check again. It'll eventually give it to us. I hope. Well, I can. Oh, if I do this, it usually changes it on me, though. I don't know. Maybe you're seeing the method is right. I just can't see. That's 90. So did I do something? So the greatest rate of increase was the rate. The rate was 90 points per day. On what day did the index show the greatest rate of decrease? Well, if 100's correct, then 11's correct. If 11's correct, 100's correct. Oh, now, yeah, so it wasn't that. I guess I can do a guess and check. So that one was right. Sorry about this, folks. Oh, the rate was negative. I think you guys got on me. That's negative. Negative. Usually when they say decrease, I say, okay, that includes the negative. There we go. Thank you. I'm glad I thought I was going crazy. Negative 100 points a day. Negative slope. Okay, sorry for that. You guys are all on top of that. Okay, an object dropped from rest at the top of a building on planet X falls at a distance of 17 t squared feet in the first t seconds. Find the average rate of change of distance with respect to time as t changes from t3 to 9. Okay, this is the average rate of change. Okay, so what we need is we need d of 3, and we need d of 9, and again we get that with 17. This will be 3 squared, this will be 17 9 squared, and then we need to get the rate of change. Now these two numbers, these will be the y values, and in the bottom we'll subtract off the x values. Now, we can do it with a slope formula, right? So the bottom is going to be 9 minus 3, which is 6. Whatever we get here, this is going to be 9 times 17. 9 times 17. times 17. 153. And then it's going to be 81 times 17. Yeah, I don't know if, well, it's a big change there. 1377. So those are the two values we've got. Again, while we're here, we know we can subtract the two, so I can take 1377. 1377 minus 153. So I'll just go ahead and, so 1377, I'm just going to put minus 153, so that takes that answer, subtracts that. So that's 1224. We divide that by 6. So we get our rate of change of 204 feet per second. 204 feet per second. Right, and this was 1224. This is 204. And it's all positive, so this is a starting drop from rest. The average velocity usually has rate of change. The distance in feet, so that's how much it's falling. I would say it should be negative because it's going towards the ground, but after 3 seconds, it's fallen 153. It's falling more. Average velocity or speed. Now, speed doesn't have direction. Let's check it. It might need yeah. So it's kind of confusing to think dropping would be like a negative because you're getting closer to the ground, but it's not measuring from the ground, it's measuring how far it drops, so it's measuring from the location on the building. Up to 14 already. Let's see how far we get. Find an equation of the tangent line to this graph. Okay. I'm going to show you a little technology, and then I'll come back and do it old school as well. So your graphing calculator has a tangent function. You can actually draw it. So let's go. We go in and put the equation -2x to the third. So that's what we're going to graph. Notice we're going from 2. The point on this graph is 2, -16. So it kind of helps with our window setting. We know we want to be able to see at least down to -16, right? Let's go with -25, and I think that'll get it pretty nice. Now the x, we're only looking at x equals to 2, so let's back off. Let's go to 5 and -5. This will just allow us to see it more clearly. Okay. So this is what our graph looks like when x is 2, y is -16, and they want the tangent line. So the way we do a tangent line is there's this thing called draw. See, it's in blue right here, right above the program key. You click on the second because it's to activate the shifted function. We're going to draw. We're actually going to draw a tangent line. So that's number 5. And the way the tangent line is, it does. You're just sitting here waiting. What's it waiting for? It's asking for what x value do you want that tangent line at? We want that x value to be 2. So what we do is we just click on 2. Notice we got x equals 2. Now we hit enter. Watch this thing. It's going to draw the tangent line. It marks it there, and it gives us the equation of the tangent line. Isn't that just like wonderful? I'm going to show you how to do it by hand as well, but if you got a TI-84 calculator, the 83 will do it as well. We get our equation y equals negative 24. We'll just round it to negative 24. I'm sure that's good enough. X plus 32. End of story. So they've got the y equals already, so we're going to put that in, negative 24x plus 32. I'm just going to go ahead and check it, just so that we can all, yep, it's good. Now that I've done that, say you don't have a TI-84. Casio, I think, also does it. There's other, anyway, if you've got a different one, my suggestion is to take a look online. They'll show you how to do that. Look up tangent line, and they'll get you there. Now, if you have to do this by hand, what you do is you have to, the slope of the tangent line comes from the derivative, so I want you to understand how this all works. So we take the derivative of f of x, and that's going to be 3 times 2 is negative 6 x squared, right? 3 times 2 is negative 6 x squared, and then subtract 1 from the exponent. Now, this is our generalized slope. We want it at the point 2, negative 16, so we plug in 2 for x. So the slope at 2, negative 6, 2 squared, that's 4. Negative 6 times 4 is negative 24, so that is our slope. You know we got y equals negative 24x plus b. Now you could use the point slope formula. I like to just use the plug in the point formula. So I've got this, this is an x value, this is a y value. So I plug in 2 for x, and I plug in negative 16 for y, and then I solve for b. So I get negative 16, this is going to be negative 48. Add 48 to both sides, and you get b is equal to 32. So that's how you could get this same answer, sort of the old school, the longhand way. Derivative, find the slope, plug it into the linear equation, plug the point in and get it. I like the calculator. And because the calculator, the other thing is, it showed me the tangent line. I understood the concepts more clearly using that technology. Oh, we already checked it. We know we're good, but sometimes when you get it right, you just want to try again. So we got maybe 6 more problems, maybe 7. So now we have to differentiate. We could do this, right? So remember, we rewrite this to take y prime. We're going to rewrite this as 20x to the 1/2. And the way we go about taking a derivative is the exponent comes down, and we're going to multiply by 1/2, and then we're going to subtract 1 from the exponent. Now, since to subtract fractions you need common denominators, let's subtract 2 over 2, which is another way to write 1. So we get 20 times 1/2, or 20 divided by 2. That's going to give us 10x. Subtract 2 over 2 from 1/2, so that's going to give us a negative 1/2. Now, they didn't say anything about not having or having positive exponents, or even putting them back as a radical. Let's just see if they'll accept it as is. I'm not always certain. I mean, I would, but there we go. Oh, forgot negative in front, right? should accept that. If they don't, we'll, yeah, it was just fine. So you could put it as a radical. You could also, just to show you, you know, if you wanted to, the 10 would stay on top. You could rewrite this as 10 over radical x. This would also be correct, but, you know, multiple ways to do things. Multiple ways. Clear, go. I think I'll get 5 more, but we're on a good roll here. So let's take this derivative. Of course, these are probably all the ones that you don't have problems with. That you want the later ones, but I'll get to them in the morning with a fresh mind. So we just need to take this derivative. Actually, it's just so the derivative of 9x to the 1, so that's going to be 9. Subtract 1, that's going to be x to the 0, which is 1. So this is our answer. And then when you take the derivative of a constant, you get 0. Derivative is just 9. And that sort of fits. Remember, the slope of a line is the number in front of the x. The slope, so it's a constant slope. Derivative is 9. Okay. 17. Let's clear this out. And you know, once I get done here, I've got to upload this, so it takes a little bit of time. But so we just want to rewrite this. I'm going to, so this is x over 6, or you could write it as 1/6 x to the 1, and then this over x, I'm going to rewrite that as 6 x to the minus 1. Okay, so to take this, the 1 comes down, so 1 times, we get 1/6, right? Subtract 1 from the exponent, that's 0. Come on. So that's x to the 0, which is 1, so this is that derivative. Now with this one, the negative 1 comes down, so negative 6 times negative 1 is a plus 6. Remember, we're subtracting 1 from the exponent. Negative 1 minus 1 is now x to the minus 2. And again, it should just accept it as is. You could move that down to the denominator if you wanted to, but divided by 6 over this, though it needs to be a plus, and then we get 6x raised to the negative 2. Okay. And again, take this, do this multiple times, see how they, you know, if you're not sure about the answers, this I think gives you multiple times through. At least it's doing that for me. Okay, we all good? So let's go to 18. For the function, find the points on the graph at which the tangent line has slope 1. So we want the tangent line to have slope 1. So what we need to do is first get the equation for the tangent line, which is taking the derivative. So we're going to find y prime, and then we're going to set it equal to 1. Okay, so to take this derivative, the 2 comes down, so we're going to have now negative 2 times 0.25 should be 0.05. And then you subtract 1 from the exponent, so that's x to the 1 power. Okay, and then the second part, the 1 comes down, 1 times 3 is 3, and then you subtract 1 from the exponent, so that's x to the 0, which is 1. So this is our formula for the derivative, which is also going to be the tangent. So what we do is we want it to have a slope of 1, so we set it equal to 1. So we say that 1 is equal to negative 0.05 x plus 3. What value will that be? Well, we subtract 3 from both sides. That's going to give us a negative 2. And then we're going to have to divide by negative 0.05. going to be x. It's going to be a positive value. We're dividing by this. That's going to be like 200, something like that. 2 divided by 5. 200? 100 maybe. It's 2 divided by 0.05. No, divided. 2 divided by 0.05. 40. I couldn't figure out. That's why I used the calculator. Okay, so that's 40. Positive. I could tell you it was going to be positive. Okay. Now that's not the answer though, because that's not a point. That's an x-coordinate. And so now we need to do, because that's why we got this calculator up here, is we've got to plug in that 40 into the original function to get the y value. Okay, so I'll show you. We're getting the first coordinate, 40, the x coordinate. Now we need to plug into this formula. Let's clear this out. So that's point, actually negative, right? Negative 0.025. We're plugging in 40. Squaring it, and plus 3, and for x we're going to plug in 40. So 80. The y value is 80. And remember to put your parentheses there. There's a comma to separate it, but there's only one. There's only one place. Because it's a linear equation. Only one place it's going to happen. There we go. We're good. And use the product rule to find the derivative of the given function. And then we can fill it in on one of these. So product rule. Let's see. The way I like to think of the product rule, we've got a left and we've got a right. So when we use the product rule, we take the derivative of the left times the right unchanged plus the left unchanged times the derivative of the right. Come on. So the derivative of the left is just going to be derivative of x minus 3 is just 1. So we end up with 1 times the right unchanged. Then we take the derivative of the right, which is just 1, right? Just x to the 1 power, that's 1, times the left unchanged. So they want to do a little bit here, so which one is this? So use the product rule to find the derivative of the function, select the correct answer below, and fill in the answer box for your choices. So yeah, I mean, you could actually come up with the answer, but that won't help you. They really want the process. So the process is I think, let's see, the derivative is I guess you could do it either way. This one will be closest. The thing is they switch the order, but you know, you can do any one first you want. You could do the right first. Maybe that's how they taught it, right? So x minus 3 times the derivative of the other one, and then x plus 5 times the derivative of the other one. That's the only one that makes any sense. Now when you expand it, this is a good way to check it out. Foil it out. I didn't realize there's more to this, so we get x squared, right? X times x, and then x times plus 5 plus 5x, negative 3 times x, so it's negative 3x, and then negative 3 times 5, negative 15. And so that gives us x squared plus 2x minus 15. So that's what we can put there. And notice when we're done, we'll get 2x plus 2. If we do that, that's what we would get if we expand out there. So it'll work both ways. But they don't want any calculus done here. They just want it foiled out. X squared plus 2x minus 15. And then doing this either approach. So we've got it up here already. We've got it 2x plus 2. Looks like it's gonna work. Okay, so you can expand out there. 100% correct. So we're good. Okay. It's a nice little thing to do. Let me do one more, and then I'm gonna get some sleep, and then in the morning maybe I get the next 20 done first thing. I usually wake up pretty early. Let's see what we can do. 20. Yeah, you have to give me the quotient rule. Okay, so this one. So with the quotient, just in general, we've got a top and a bottom, right? So we'll call it a high and a low. And when we take its derivative, we take, we just write the low one times d high, the derivative of the high, minus the high one, original version, times d low. And then in the denominator, we get low low. So low d high minus high d low over low low. It's a little rhyme we had back in the 80s. Maybe you're familiar with it. So what I'm going to do is I'm going to take the derivative. Let me come over here. I'll take the derivative of the high, and then we'll put all the pieces together. So the derivative of the high is going to be 2 times 2 is 4. Come on. And then I subtract 1 from the exponent, so 2 minus 1 is 1. And then the derivative of negative 5, it's a constant, is 0. So that's the derivative of the high. The derivative of the low, 3 times 5 is 15. X squared, right? 3 minus 1, and then the constant is the derivative constant 0. So now when we do this, we take low, and again the original low, so that's going to be 5x to the third plus 4 times d high. D high is the derivative of the high, 4x, minus high, the original high, 2x squared minus 5, d low, and d low is the derivative of the low, 15x squared, all over low low. So this is the low, the original low, 5x to the third plus 4, and that's going to be squared. That's our answer. Now, they didn't even ask to simplify, but again, I wouldn't want to. We could, but anyway, don't have to. So don't do things you don't have to do, especially when you don't want to, and it's not a lot of fun. Let's see, plus 4. That's it. And then 4x. And then we got minus parentheses 2x squared minus, come down, minus 5, and then that's just times 15x squared. Come to the bottom. Did we? Yeah, there we are. Come to the bottom, and we've got 5x cubed plus 4. Oops. No, come down, arrow, plus 4. And then little caret exponent squared. Okay. Now, the reason all this happens, it's the formula, but remember, kind of when we were taking, early on, if you take a derivative of 1 over x, that's x to the minus 1, right? So that's a denominator. When you take it, you're going to get a negative coming off. That's why the negative in the middle, right? You get negative x. And then when you subtract here, you're going to subtract 1, you're going to get squared, negative squared, right? But that's where the square comes from. It's just because you're dealing with it. And the other parts is, from the product rule, so it's kind of a combination there. Anyway, let's just check it. It's right. Better be. They don't pay me all this money to be a math teacher for getting the answers wrong, do they? So anyway, let's take a peek. Maybe I got one more in me. Question 21. Differentiate the following. So now we got to use a chain rule. So that's a good place to stop after I do this one. So we've done a product rule, quotient rule, and chain rule. You'll be able to look over these, and then I'll do the remaining questions, however many, 20 more, 19 more, I'm not sure. So when we're doing the derivative of something with an inside part and an outside part, what we can do is we take the derivative of the outside part, so it's just going to take this 2, bring it down in front, multiply by that, and then subtract 1 from the exponent. And then we've got to remember the chain rule says then multiply by the derivative of the inside. So we get 2x to the 5th minus 7x all to the 1 power. And then we need to multiply by the derivative of what's on the inside. The inside is going to be 5. 5 comes down, x to the 4th, right? 5 comes down, subtract 1, you got 4. Second part, there's a 1 up here. The 1 comes down, so 1 times negative 7 is negative 7. Then you get x to the 0, which is 1. So there's our answer. That's the chain rule. Derivative of the inside times the derivative of the outside. And let's go ahead and put that up. X to the 5th, arrow over, minus 7x. And then we're going to multiply. You don't have to put multiply with, you just put the parentheses, minus 7. Hey, I think this, we got it all? I think that's good. We've been doing pretty good tonight, as soon as I figured out about that negative sign, right? So I'm going to call it good for now. Get this uploaded, so you, those of you who like to stay up late and work on things, you should see this. I'll put an announcement, and then I'll finish up the remaining problems in the morning and post another announcement. Good luck, have a wonderful weekend, and get lots of studying done. We'll talk to you later.